Welcome back to Geometry Classroom. Today we'll talk about inscribed angle. We have a few objectives for this lesson. First, we'll define an inscribed angle. We'll learn how to identify such an inscribed angle. Then we'll learn about the properties of inscribed angles and how to use these properties to solve problems. But before that, let's talk about inscribed angle. What is an inscribed angle? An inscribed angle is an angle whose vertex is on the circle and whose sides are chords of the circle. So don't forget, an inscribed angle has its vertex on the circle and its sides are chords of the circle. Next, the inscribed angle theorem states that the measure of an inscribed angle is half the measure of its intercepted arc. But what is the intercepted arc? The intercepted arc is the arc that is cut off by the sides of the inscribed angle. For example, in this picture, right, these are the sides of the inscribed angle, right? And this is its vertex, right? Now, the sides of the inscribed angle, right, intersect our circle into 2 points, right? D and F, right? Now, the portion on the circle that is between these points, in other words, the portion on the circle that is between the points of intersection between the sides of the inscribed angle and the circle, right, is called intercepted arc. That is intercepted arc, right? And the inscribed angle theorem states the measure of this inscribed angle is half of the measure of the intercepted arc. Next, let's talk about properties of inscribed angles. First case, property, if two inscribed angles, right, like these angles, intercept the same arc, right? They intercept the same arc, then these two inscribed angles are congruent. Second property, an angle inscribed in a semicircle, right, is a right angle. For example, this is an inscribed angle, right? Why? Because its vertex is on the circle. Now, if this angle, right, is inscribed in a semicircle, right, like this, or if its intercepted arc is a semicircle, then this angle, inscribed angle, is a right angle. Yeah, this is 90 degrees. And the third property, the opposite angles of a quadrilateral inscribed in a circle are supplementary. In other words, angles A plus C equals 180 and angles B plus D equals 180. But probably you'll ask me, what is inscribed quadrilaterals? An inscribed quadrilaterals is a quadrilateral, right, is a shape with 4 sides and 4 angles, whose vertices or angles are all 4 inscribed angles, or is a quadrilateral whose vertices are on the circle. Good. Next, let's have a few problems with inscribed angles. In these problems, we'll use the properties of inscribed angles and inscribed angle theorem to solve these problems. Now, in this example, find the measure of the angle indicated. In this case, we need the measure of this angle, right? Now, this is an inscribed angle. Why? Because its vertex is on the circle. We know the measure of angle I, right, would be half of its intercepted arc, right? Its intercepted arc is the arc bounded by points, let's say S and F, right? So, would be 198 degrees divided by 2, right? So, would be 99 degrees. So, the measure of the inscribed angle SIF would be 99 degrees. Good. Another example. In this example, it says find the measure of the arc TR. So, in this example, we need to find the arc, the intercepted arc, right, of the inscribed angle S, right? This is the inscribed angle S. Now, as we know, according to inscribed angle theorem, the measure of the inscribed angle is half of its intercepted arc, which is, in our example, TR, right? Now, we're going to write measure of angle S, which is 42 degrees, right? Because it's 42, equals fraction line, yeah, is half of its intercepted arc. Let's say measure of arc TR over 2. Now, to find the measure of arc TR, right, we have to get rid of 2 because 2 is in the denominator of the fraction, right? To get rid of 2, we have to apply the inverse operation of division, which is multiplication. So we have to multiply by 2 both sides, right? 2 and 2 divide out. So we're going to have 84 degrees, yeah, because 2 times 42 equals 84, equals measure of arc TR. So, when we deal with inscribed angles, we have probably 2 main types of problems. When the measure of the inscribed angle is given, and we need to find the measure of the intercepted arc. When we have such a case, right, we have to multiply by 2 the measure of the inscribed angle to get the measure of the intercepted arc. The second type is when the intercepted arc is given and we need the measure of the inscribed angle. In this case, we have to divide the measure of the intercepted arc by 2 to get the measure of the inscribed angle. Good? Another example. In this example, it says find the value of x. So here we have the measure of the inscribed angle, right? Which is 7x plus 9, and the measure of its intercepted arc, right? Its intercepted arc has a measure of 46 degrees. Now, we write the equation according to inscribed angle theorem. Yeah? The measure of the inscribed angle, which is 7x plus 9, equals half of its intercepted arc. So, would be 46 divided by 2. 46 divided by 2 would be 23. So, we have 7x plus 9 equals 23. Then we solve for x. We subtract 9 on both sides. We get 7x equals 23 minus 9 equals 14. Then to get x, we divide by 7, and we get x equals 2. Good. And another example. Find the measure of angle F. We need a measure of angle F. So, in this case, we have two inscribed angles. Why? Because the vertices of these angles are on the circle. But as we can see, these inscribed angles, right? Both, right, intercept the same arc, right? Their intercepted arc is this one. According to the property of one of the properties of inscribed angles, when two inscribed angles intercept the same arc, they are congruent. So, because they are congruent, the measure of these two angles is the same, right? So, we can write an equation, 8x plus 6 equals 10x minus 4. And we solve for x. First, we have to combine x terms. We subtract 8x on both sides. We get 6 equals 10x minus 8x equals 2x. We bring down negative 4. Then we add 4 on both sides. And we get on the left side 10 equals 2x. Then to get x, we divide by 2, both sides, and we get 5 equals x. Good. But it says find the measure of angle F. And angle F is this angle, right? We simply plug in. So you're going to have 10 times 5 minus 4, which is 50 minus 4, which is 46 degrees. So the measure of angle F would be 46 degrees. Thank you for watching my video. Next time we'll talk about other types of properties that are valid for circles. Thank you for watching my video.